Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about photochemistry. So what is photochemistry? Photochemistry is a study of reactions that are brought about by the actions of visible or ultraviolet light. One of the most common example of photochemical reactions is the process of photosynthesis in the plants by means of sunlight. You can see here carbon dioxide react with water in presence of sunlight under the conditions of chlorophyll. You will get the carbohydrate and oxygen. So this is one example of photochemistry. Now, photochemical energy. Photochemical energy. So photochemical energy, you can see here epsilon is equal to h nu. Here epsilon energy per quantum, h Planck's constant, and nu frequency of radiation in cycle per second or hertz. Nu is equal to c by lambda, where lambda wavelength in centimeter and c velocity of light centimeter per second. So energy is equal to nh nu, nhc divided by lambda, where n is Avogadro number, E energy per mole. Then if you put all the constant, you will get 2.86 into 10⁴ divided by lambda nanometer kilocalorie per mole. So this is the energy of photochemistry. Now electronic excitations. You can see the ground state, which is bonding orbital, and anti-bonding orbital, and atomic orbital. Two atomic orbital combine forming molecular orbital, and molecular orbital have one bonding orbital and another anti-bonding orbital. Bonding orbital have lower energy than anti-bonding molecular orbital. So there are many transition possible. You can see here energy sigma sigma star, pi pi star, n pi star. So sigma sigma star energy is very high, pi pi star energy is less, and n to pi star transitions are very less. So n to pi star transition and pi to pi star transitions is important in organic chemistry. Now excited state, modes of dissipation of energy. Excited state, modes of dissipation of energy. You can see S0, S1 and T1. S0 is your ground state and S1 is singlet state, singlet excited state, and T1 is triplet excited state. So you can see, especially in case of pi pi star transition, S0 2 electrons in the ground state. In singlet state, electrons jump from ground state to excited state pi star without changing the direction of electron. But in triplet state, now you can see bonding orbital electron direction change. So you can see here intersystem crossing in benzophenone. What is the meaning of intersystem crossing? Here you can see S1 first excited state and T1 triplet excited state, and in between there is energy, and that energy is known as ISC, inter-system crossing, and that is very important. Now you can see the possible route to loss of excitation energy. You can see here ground state is 0, first singlet transition is 1, second singlet transitions is 2. So S2 to S1, that is internal conversion. S1 to T1, that is inter-system crossing. And then you can see triplet to S0 phosphorescence, S1 to ground state fluorescence. So there are four important transitions energy level like phosphorescence, fluorescence, internal conversion, intersystem crossing. So internal conversions from S2 to S1 and S1 to T1, that is the intersystem crossing. Now two phenomenon, and that phenomenon is fluorescence from S1 to S0 and T1 to S0, that is the phosphorescence. And RD for radiations, here H nu absorptions. So non-radiative transitions like RD and transition with absorptions or emission of radiation, that will show by this line. Now Jablonski diagram you can see here. S0, S1 and S2. S2 to S1 IC. In between there is a lot of vibrational energy level. S1 to T1, in between there is a lot of vibrational energy level. Now you can see the absorptions from S0 to higher energy level, and S1, S2 and to S1, S1 to S0. So S1 to S0 is fluorescence and T1 to S0 phosphorescence. Now you can see this pictorial diagram S0 to S1. There are S0 fluorescence or intersystem crossing, S1 to chemical reaction, S1 to S0 plus AS1, S1 intersystem crossing T1, and fragmentation two species. Now you can see T1 undergo S0, T1 undergo chemical reactions, T1 react with A plus, it give S0 plus A T1, and T1 fragmentation two species. This is the sequence of reactions in photochemistry. Now let us look at one example. Here one, this is diene system. It undergo S1, it give two products, 2 and 3. And if we'll go through the T1 state, dimerization occurs. And you can see the 4, 5, 6 dimeric structure of diene. Now energy transfer. This one is also very important. Here you can see D after getting H nu, singlet D. D for donor. Now singlet D undergo intersystem crossing forming triplet D, triplet donor. Now A plus 3D, A for acceptor, undergo collisions and donor transfer their energy to acceptor A. Now 3 acceptor or triplet acceptor give the product. So 1 indicates singlet, 3 indicate triplet, D indicate donor, and A indicate acceptor. So you can see here, that's this pictorial diagram. S0 to S1, this is the energy level in case of benzophenone. And S1 and T1, there is a phenomenon intersystem crossing. There is an energy gap between them. So 69 kilocalorie per mole. Now, triplet, here energy transfer T1. So 60 kilocalorie per mole. So S1 to S0 in case of butadiene. So mechanism of energy transfer, you will understand how benzophenone transfer their energy to butadiene. You can see the benzophenone. It undergo singlet excited state, intersystem crossing triplet excited state. Now butadiene is there. Now this transfer to triplet to butadiene. Now triplet butadiene which undergo reaction, it give 4, 5, 6 dimerized form. So sense means sensitizer. It undergoes singlet sensitizer undergo triplet sensitizer, and triplet sensitizer react with reactant and it gives triplet reactants. So intramolecular energy transfer. So these molecules you can see benzophenone is there and reactions occurs. You can see in examples 8 there is a CO group, there is a double bonds. Here reaction occurs in the presence of light into pi transitions, and what will happen here, you can see this trans converted into cis. Now quantum efficiency. What is quantum efficiency? Quantum means phi, number of molecules reacting or formed in unit time, and number of quanta absorbed in unit time. That ratio is known as quantum. Now simple example you can see. Cl2, it gives Cl radical, Cl radical. Cl radical react with H2, it gives HCl and H radical. H radical react with Cl2, it gives HCl and Cl radical. Now important functional group, carbonyl compounds, where N to pi star transition and pi pi star transition is possible. Look at here the structure of CO. Here double bond and lone pair is there. So pi pi star transition and N to pi star transition, both transition possible in case of carbonyl system. So photo reductions of carbonyl. You have benzophenone, you have alcohol. It gives this product under N to pi star transition by removal of dimethyl acetone. Acetone. So diol formations. You can see CH3COCH3 and CH3CHOH-CH3. It gives combined product through the N to pi star transitions. If you have benzophenone, it undergo reaction, it gives singlet, and then intersystem crossing, it gives triplet benzophenone. So look at here the situations of two electrons breaking of pi and 12. You can see the R, two lone pair of electron and one non-bonded electron. So acetophenone, benzophenone react with alcoholic, it gives these products, and these two products combine together forming diol system. Now you can see the benzophenone how react with alcohol and forming these products, and after undergo dimerization, it gives the diones, which is 10. So you look at here, energy. Benzophenone and substitute a benzophenone. What will happen here? N to pi star and pi pi star transition is high in case of benzo, but if you add N-dimethyl in both para position, N to pi star and pi pi star transitions will decrease their energy. So you can see the reactions, how reaction occurs, photoreduction. Here you have the CO groups. It will undergo excitations forming these products. In the same way, Nordic type 1 reaction. So in second lecture, I will discuss about the Nordic type 1 reactions. Thanks for watching. If you like this type of video, then subscribe my channel, and thanks for watching.